This is first wrong step, an education track tutor for typed, step-by-step linear equations. Instead of grading only the final answer, it finds the earliest algebra move that changes the solution set, gives one restrained teaching prompt, and asks the learner to prove the skill on a new problem. The public judge path needs no account, student data, API key, or paid service. I will load the synthetic distribution example. The learner can inspect and edit every equation line, while the exact analysis runs locally and deterministically in the browser. When I check the work, the app stops at step 2. 3 times the quantity x plus 2 was incorrectly changed to 3x plus 2. The validator identifies distribution as the relevant category, explains that the outside factor must reach every term, and deliberately leaves later steps unevaluated. The small hint asks one focused question without revealing the answer. It is labeled as a review judge fixture and static content, with no live model call. I repair step 2 to 3x plus 6 equals 18, then finish with 3x equals 12 and x equals 4. Rechecking confirms that every transformation preserves the original solution set. The attempt history keeps the first diagnosis and records the second submission as a repair of attempt 1. Correction alone is not mastery. The app now generates a changed coefficient problem in the same distribution skill family, 4 times the quantity x minus 2 equals 20. This candidate was machine validated before display, and the learner enters 7. The transfer answer is checked by exact rational algebra, not a language model. Because the original reasoning is now valid and the independent transfer response is correct, mastery changes from in progress to mastered. The read-only evidence view summarizes the current browser session, 2 immutable attempts, the first invalid transition, governing rule, reviewed hint provenance, repaired steps, transfer problem, response, and deterministic mastery. It is explicitly not an account, grad ebook, or shared student record, and the work is not persisted. The build view documents how I made the project. I first created and refined a reusable Greenfield Software Factory skill in Codex using GPT-5.6 Sol with ultra reasoning. I then invoked that skill to drive requirements, architecture, dependency ordered planning, bounded implementation, automated testing, independent review, and evidence-backed repair. Codex coordinated the factory workflow and maintained the project artifacts, while GPT-5.6 Sol Ultra helped reason through the product specification, architecture, test design, repair decisions, and the reviewed teaching copy. The mathematical runtime remains deliberately separate. Exact deterministic code decides whether a step is valid, whether an answer is correct, and whether mastery is achieved. GPT-5.6 assisted pedagogy is versioned, reviewed, static content, not a live GPT-5.6 runtime API. First wrong step turns a wrong answer into an auditable learning loop. Locate the first broken transformation, offer the smallest useful prompt, preserve the repair history, and verify transfer before claiming mastery. The public app and source repository are available from the submission.